As I'm not sure where you might be in terms of logs and how much you know and how much you've explored about logs or logarithms in the past, I'm going to start at the beginning, and for those of you who might never have touched on logs. So I would say that the most important thing to do with logs is to learn the definition of what a log actually means. Now, you might be wondering why we're doing logs after indices, and there is a really good reason. The reason is, as you know, to take the square root of something undoes squaring it. So if I square 3, I get 9. If I take the square root of 9, it gets me back to 3. Likewise, logs undoes, taking the log of a number undoes what raising a number to a power actually does. So for example, you know that 10 squared is equal to 100. If I was to take the log then of 100 to base 10, I get back to the index. Logs, taking the log of a number produces the index. That's the connection between indices and logs. Raising some number to an index, this index produces a number, taking the log of that number, obviously to a given base, gives me back the index. Now I'm saying obviously to this base because think about this. We know that 2 to the power 4 is 16. If I take the log of 16, now I must take it to base 2 to get power 4. The log of 16 to base 2 gives me 4. Because remember, taking the log of the number gives me the power. We also know that 4 squared is 16. So I could again take the log of 16, and this is why I have to state what the base was. You'll get 16 when the base is 4 and the power is 2. So let me just go over those again. If you take the log of 100 when the base is 10, you get the power 2. When you take the log of the number 16 and the base is 2, you will get the power 4. So you're getting the power to which a base has to be raised. Where that's really going to help us is when we've got a to the x, and we want to know what is that x. If we know that a to the x, for example, is equal to b, what I know is I can take the log of b to base a and it gives me x. So logs and indices are the reverse, create the reverse operation to one another. And secondly, taking the log of a particular number enables me to find a power. Okay, the definition is the most important part of this exercise, and by definition, the log of a number y, so the log of 16, to a given base, and the base might change, so in this case to base 4, is the power, yes, it is the power, to which that base, 4 in this case, had to be raised in order to give me the number I'm taking the log of. So the log of a number y to a given base a is the power x to which the base a must be raised in order to give y. That sounds probably just like double Dutch at the moment. However, it has to be something that you can recite and fully understand. So it says if you've got the log of this number y to this base a, it's the base a, and you get x, it then means that the base a, the powers x, will give you y. And like I said, it demonstrates the connection between logs and exponentials or powers, exponents and powers. In fact, they are the inverse of one another. They're the opposite. They undo one another, like squaring and square root. Some examples. We know that 2 to the power 3 is 8. If we take the log of 8 to this base, and we've always called this the base, and the 3 was the index or the power or the exponent, then the log of the number to the given base gives the power, gives me 3, to which 2 would need to be raised to in order to get 8. We've got 3 squared is 9. Then we want the log of 9 to base 3, and that will be 2. 4 to the power 1 is 4. Then the log to base 4 of 4 is 1. And if the power is 0 of this number 1, and gives 1, when the base is 5, we have, for example, 5 to the 0 power, then of course, yes, that's 1. We know that. Just remember, the base of the log and the base of the power are the same. They're the base. The base of the log, the base of the power. Just one more thing. We call this log of the number. This is a number. To a given base is equal to the power. I think I'll stop the video there and do some examples in another video.